And we'll hit record here.
Recording in progress.
All right, welcome everybody. It's spring 2022. We are in CSCI 001, Introduction to Programming and Methods. We're using C++. And this module, we are going over looping structures, iterative approaches to looping structures. So module 5 is iterative approaches to looping structures. So let's put in our good old include IO stream. And we'll do using namespace. And we'll do an int main void. And when you have int there, you really, I saw this in a lot of homeworks. People weren't doing the return 0. You can't automatically assume that every IDE or compiler will work without that return. So you really should have a return in there if you've got int as the main. While I'm talking about the homework, there's been some announcements this week about plagiarism and stuff like that, copying from another source. I strongly encourage you to work with each other and learn from each other. I do not mind you looking at my lecture notes and for guidance and stuff like that. That's why I posted them. You do not want to just copy and paste and do slight edits. The reason why is that's very much like tracing when you're doing art. If you tried to trace the Mona Lisa and you come up with a tracing of the Mona Lisa by putting tracing paper over it, God, you would piss people off. But if you did, and trace picture Mona Lisa, you didn't make the Mona Lisa. No matter how good you think you made it, you didn't do that because you copied someone else's work. And the skills that you acquire in doing, like being able to draw the Mona Lisa, paint the Mona Lisa, you don't have those skills the same way you don't have those skills in programming. Filling in, editing someone else's work just doesn't work. I do want you to work with each other, though. I can't express that enough. The best way to gain skills in this is it's a lot easier to talk to someone that knows what they're doing and go, hey, what should you do here? Don't just copy their code word for word. Like, try to figure out what it means and adapt it to your own. Okay? In fact, as I was telling Adrian about some of the rampant plagiarism, and he was saying what great programmers you guys are getting to be because you're already good at copying and cheating, or copying and pasting someone else's work. While in the long run, that happens in real life quite a bit. You will speed up your work so much if you just copy and paste from other work you already know how to use, and it saves you the time from creating it. But if you can't create it on your own in the first place, that's a terrible way to go because you don't know what it does. For example, when I said make a global constant, a couple students used define pi. Define, I've never used define. We don't teach define in either of the CSCI2 classes. It does create a macro, and it does, for the use it was created, it worked, but it was not a global constant variable. And whether if you're good enough and you have enough skills and you know what define is, good. But for now, just pretend you don't and just follow the rules of the assignment and go with it as it is. Make the global constant as requested. Because as it is now, it just looks like a copy and paste job. And we don't want to do that. I need to make sure you know how to do this stuff before I can send you on to CSCI2 for next semester. I need to make sure you understand the basics, that you're not just good at copying and pasting. There isn't going to be any repercussion for the first 3 modules like that, but I am kicking them back and asking you to redo them. Okay? So, no one's in trouble. And if you've fallen behind, I'm still, like, it'll give you a 0 when I grade it, but I'm going to go through, when you turn it in late, it'll give you a 0. If you resubmit something, it's going to give you a 0. But then I go through and I edit the grades on my own, and I'm going to assign the appropriate grades. So you can always, if you've fallen behind, catch up. Okay? We do have a midterm coming up. Well, not a midterm, a test coming up next week on Wednesday. And this weekend, Friday and Monday, are both holiday days. Having said that, though, on Monday, I am going to do something at 4 o'clock to 6 o'clock if anyone wants to show up. I'm going to go over like a review problem, a couple review problems I posted in Canvas on how to do some of the stuff. Just as a refresher, of course, you'll be on a holiday. We're all on holidays, but I want to make sure you guys have that opportunity to see it. So let's get started with looping structures. The first these looping structures we're going to do include while, do or do while, and the for loop. Those are the standard ones. I'm also going to show you goto, the goto command. Professor Redden doesn't like to show it. He's not a big fan of the command. It can cause glitches, but if you use it appropriately, it doesn't. So the while loop is a pre-test loop. Which means it tests the condition before running. And the default setup is you say while, then you put the curly braces, your test condition. Not curly braces, that's totally wrong. It's parentheses. While, parentheses, test condition. And then use curly braces for your code. I bet I should just put that on one line. Code goes here. And then you end it with a curly brace. So let's look at some examples. I'm going to make, let's make some variables. Integer x equals 0. We can do int y equals 0. Or let's go with y equals 10. And let's make another one just in case we need it later. Z equals 15. So an example of a while loop is I'm going to say while. And one loop I could do is x is less than or equal to 10. And then I'm going to put my curly braces and my code goes here. If you don't use curly braces, it's like the other things we've done. It only does the first line. It's also important to note that whatever variable or index that is being used in the test condition better change, must change. So in this case, I'll just do a cout. I'll say cout the value of x, and I'll cout x. And I'll show you what happens if I don't change the value of x. The x's value has not changed. All I've got is a cout in here. And if I hit run, it just keeps going and going and going and going and going and going and going. It goes forever. So we don't want that. So what I'm going to do is change the value at x. And this says while x is less than or equal to 10. So maybe I could just add 1 to x. I could say x equals x plus 1. And now if I do the loop, let's put something after the while loop. Let's do a cout afterwards. Cout. My while loop ended. The value of x afterwards is x. If we take a look at this, so it started off, I did start off with the value of x equals 0. That was my int x equals 0 right there. And then it just did the value of x equals 0. The next line, it said x, which is 0, equals 0 plus 1. X equals 0 plus 1. X is set equal to 1. And it restarts the loop. So when you get to the bottom of the loop, it restarts the loop at the test condition. So it runs through and it does a C out of the value of x equals 1. Then it reassigns x to a new value. X equals the old x of 1 plus 1 is 2. X equals 2, and it finishes the loop, and it goes to the start of the loop and tests the condition. Is when x equals 2, is 2 less than or equal to 10? Yes, it is, so we're going to run the loop. So I'll put that down here. When it gets to the bottom of the loop, it restarts at the top, testing the condition. When it got all the way to doing x equals 10, it did a C out the value of x equals 10. Then it reassigned value to x equals 10 plus 1, x equals 11. And when it retested that condition, x equals 11 is not less than or equal to 10. The while loop breaks. So when the test condition is no longer met, we get out here. For this code, it occurred when x equals 11. Okay? There are other ways of doing this. We talked about this before. I don't have to do x equals x plus 1. I can do x plus plus. This is the same as x equals x plus. This is the same as x equals x plus 1. And I can run it and it'll still work. So it does all the values 0 through 10, and it gets to 11. The loop ends, and does the value of x afterwards is 11. So it still worked just fine. Now, if you want to be really crafty, you can do this instead. The value of x and combine the two. So if I turn off both of these, what this does is this does a C out of the value, then increments x. What's up, Lewis? Oh, okay. So this is a twofer line. This will do the exact same thing. Notice our code hasn't changed, 0 through 10. Then it does the loop. There is another way to increment. Let me show you how it works. It's not my preferred one. Most people don't like it. I'm going to do the same thing of the C out, the value of x. And then you do the pluses before x. What this does is it does the incrementing of x before doing the C out. So the first time we ran it, we had 0 through 10. And then it said the value afterwards was 11. Let's see what happens when I do the pluses first. Here it says, notice it goes from 1 to 11, and then it says the value of x afterwards is 11. So this misses the initial value of 0 when you do the pluses first. So this skips the 0. and isn't really a great choice. So I'm going to do a C out on that one and put that one back in. Okay. Incrementing is another way of saying increase by 1. Decrementing is decreasing by 1. We'll do that on the next one. So let's take a look at the do loop. The do loop, or do while. This is a post-test loop, which means it checks the test condition at the end of each loop, and that means it runs at least one time. The setup for the do loop is we do. I'll put in comment first. You do. You put the code in curly braces that you want to go in curly braces. And then after the curly brace ends, you do while parentheses test condition. And that one ends with a semicolon. So let's take a look at it. Do, and I'll set up the do while stuff like this. This time let's work with Y. And I had Y set up at 10. So here I'll just say while Y is greater than or equal to 0. So let's see out the value of Y. And I'm going to put a couple new lines in there, make it look a little bit better. And nope, I don't want that there. It's going to do it on each run if I do it there. That's bad. Let me do it here. And now I'll just decrement it each time. So recall this is the same as Y equals Y minus 1. And I'll do another C out afterwards. There we'll say, I'll change this to say the value my do while loop ended. And the value of Y afterwards is. So I've got my do loop, I've got a while Y is greater than or equal to 0, and we've got C out the value of Y, and then we decrement Y. So it's going to go through the whole X thing. And then we get to Y. Y starts off at 10, and it prints that out. Then it decrements it down to 9. And then it tests the condition. While Y, which is 9, is greater than 0, do the do loop. So it goes back and does the do loop again. It keeps going and keeps dropping by 1, 9 down to 8. It gets down to 0. The C out, it does the value of Y equals 0. It decrements it. Y goes down to -1. It tests the while condition. It no longer works, so the do loop ends, and it continues on after here. So code continues here after the do loop. After the do while test condition fails. Is false. And I can show you that equals 1. It runs at least one time. Let's just reassign, proving that it runs at least once. I'm going to set Y equal to -1. So Y equals -1 fails the while condition right away, but it's still going to run once. See how it ran the value of y is -1? My do while loop ended. It ran that code at least once. So that's the post-test condition one. We do have some options we can throw in there. I'm going to get rid of the y equals -1. I'll comment it out. Some other bits of code that you can use. Let's look at the break command. The if/break is probably the best way to do it. If break sequence. When the if condition is met, the looping structure ends entirely. So for example, I can throw in here an if y equals, let's go with 3. Let's end it prematurely. I'm going to say break. So the code should get here. It should do the y equals 4. It should do y equals 4. And then decrement y minus minus sets y equal to 3. And this test condition will break. Will break the loop. So this is how the break command works. If you don't have the if condition and you just do break, wherever the break is, it's going to automatically trigger it. It's probably best to put the break in brackets or curly braces, but it's, especially if you're going to do something else, like we could. I could say see out breaking here, code is too long and I'm bored. The value of y stopped at so now when I run it, doing this, if I'll put this up at the top. Right there. It should run through, and when the y equals 3 condition met, it's going to just break out of this do loop. So it did 10, 9, 8, 7, 6, 5, 4. And then it got to y equals 3, and it stopped at 3. So that's how the break condition works. There's another condition that works in these for interrupting looping structures. The continue command interrupts looping structures, skips the rest of the current loop, restarting at the top. So maybe if let's see, where do I want to do this? I'm going to do it at the very top of the do structure. I'll leave this up here. I'll do an if condition here. If y equals 7, see out, skipping 7, and then I'll hit continue. So here, it should do the 10, the 9, the 8. When it starts the 7 loop, that if sequence with the continuous thing is going to continue. It's not going to say the value of y is 7. It's going to say skipping 7. And it's probably going to break because I am skipping the decrement. But let's check it. It did. I don't have a way. It's always being stuck at 7. So maybe I should do the decrement in here as well. Y minus minus in here as well. So now if I run it, it goes 10, 9, 8. I'm skipping 7. It does the 6, 5, 4. And if I don't put that C out in there, it just skips right over it. Okay. There are some, you don't have to decrement by 1. You can decrement or increment by more than 1. I can say I did Z. Z was at 15. Z equals 15. Was up top. Do C out the value of Z. And we'll decrement Z. But I'm going to take down Z instead by 2. And then we'll do our while loop. Not our while loop, but our while condition. Z is greater than or equal to 0. And afterwards, we'll do a C out after the Z loop ends. Okay, so here I'm decrementing by 2 each time. And we can see it right here that it works. It got to 1. The 1 minus 2 is -1, so we got to the -1 condition and it ended. Now, problems with decrementing or incrementing by more than 1. If I did something like while Z equals 0 and while equals, or while 1 does not equal 0, Y does not equal 0, and while Z does not equal 0, and shit, I'll even do that up here on my X. I'll say while X does not equal 10. Because we learned that using exclamation points means not equal. Let's put a system pause here. So I'm going to run it, and we'll see what happens with the while loop. The while loop went through it, and it stopped where it was supposed to. Now the Z loop is the one I'm decrementing by 2. And it never stops. And it just keeps going. And you know what? It's kind of captivating. And we could probably wait and see how close it gets to negative infinity. But notice it didn't stop at Z equals 0. So decrementing by more than 1, decrementing or incrementing by more than 1. Can cause problems with test conditions. Yeah. So I'll turn off this while Z equals 0. Or while Z does not equal 0. And I'll put back in while Z is greater than 0. Okay. Let's take a look at that. And did the Z loop and ended appropriately. I'm going to comment out that system pause. All right, so now that we've done that, maybe I need to treat this as a comment. Let's teach you how to make programs run again. And generate a template in Visual Studio's 2022. So, new program. I'm going to make a new program real quick and show you. Actually, do I have some good ones I can change? I'm going to go back. Let's see. I'll do recursion. No, you know what? I'm being lazy. Just make a new one. Visual Studios 2022. I'll create a new project. I'm going to use the empty project, and I'm going to say creating a template. Creating a run again template. And we'll create a new source code. And then we got to go over to our modules and grab it because I don't want to type it all out by hand. I'm going to do the very thing I started off this lecture by telling you not to do it. I'm going to do it myself because I already know this stuff and I'm just speeding up my stuff. So let's come over to class and look at our modules. And you're able to do this. I want you to do this for yours. For this one particular thing. We're going to come over to Module 5, and we're going to look at the iterations looping structure. And the program template with this right here. It's got the function implementation for run again. I'm going to copy this over. And just walk through what's going on. We've got an int main right here that's occupied. It's got some code in it. We've got a function prototype that says bool run again void. If we want to go see what the bool run again program does, we look at the implementation down below. Notice it has a void. It takes in no input. It just runs on its own. It creates a char user response, so a single letter, and then asks them if they want to run again. They say yes or no. It takes in the user response. Then it does this cin.ignore with the parentheses. It cleans up the input stream, gets rid of the enter key that's stored. So when you hit enter, that's also stored. And then it tests if user response equals little y or capital Y. If that's the case, it returns true. Otherwise, it returns false. So all this program does is the function implementation, the run again function, it prompts them if they want to do it again, and it returns a true or false. So this is where you use it in the main. Do a cout, code that does not loop goes outside the do loop. Anything that you want to continue goes inside. And you do while run again. This while run again is the same thing as while run again equals true. That's what this effectively means. And so let's just run it and show you how it works. So it did the code that does not loop goes here. Loop code goes here. Would you like to run the looped code again? Yes. It reruns the looped code and that's it. I can keep saying yes. I can say big yes. I can say no, but notice the test condition didn't ask about no. It just asked about y or little y. Big Y or little y. I can enter P here. And since P is not Y or little y, it doesn't run again. It's the while condition is false, and the loop ends. So this is a great thing to add, like if you want something to repeatedly run, like remember that game loop? It's actually one of our labs for chapter 5 is take that game thing that we did in lab 4A where you guess a number and modify it so you keep asking them for new numbers where you're telling them whether they're too high or low each time until they get it. So how to make this a template. Once you've copied and pasted this into a program, I'm going to get rid of some of the extra stuff here. Nah, why not? Leave it there. I am going to do, you can click Project. You're going to click Export Template. So Project, Export Template. And I'll type this in the other main program when we run it. And you want to go with Project Template. Item Template was a pain in the ass to use. I didn't like it. If you do Project Template and just say Next, and make the name simple. So run again. Don't need an icon image. If you want to put one, I guess you could. I didn't. And I checkmark automatically import the template into Visual Studios. And you just say finish. So project, export template, and then do the template option, project template option. Oh, I already made one. Let me change the name. Run again. Number 2. Yeah, I did this earlier to make sure I knew how the project export worked. So, I'm going to close this loop and show you how you use that. Now that I've made it, I'm going to start Visual Studios. I'm going to create a new project. And if I want to use the template I just made, do not click empty project. Look for the name that you just entered. I called it Run Again Deuce. But my Run Again works just fine. I'll use that one. I'll say next. Showing off Run Again. And we click Create. And now when I notice there's a source CP already here. I didn't need to create a new one. It's already got one here. What's in it? It's got my program template in there. So you don't need to create a new source file. Just use the one that's already there if you use the program template. Doing this, especially even on the test, if you use this, copy this Run Again template, use this template on your test where you want to repeatedly do something, I'm okay with you using that kind of template. No problems there. So I encourage you to use this. You'll want to run things again often now. But back to the regular lecture notes. Now that we did that little loop. So we put in the code from the template. Click on Project. Select Export Template. And then Project Template. After that, when you start new codes, new projects, search for your template in the search bar. You really only need to do it once because after you've done it once, it shows up automatically on your recently used list. And the source code with your template is already there. No need to create a new source code. All right, so that's the do and the while, or the while and then the do while. We talked about break, we talked about continue. Now the most infamous one of all, the for loop. For loop looks like this. I guess I can tab that in. We're going to say for, and then we have an initialization thing. I'll show you what that means in a second. We hit colon inside the parentheses. Inside the parentheses. Then we have our test condition with another colon or semicolon. Then we increment or decrement as appropriate. Semicolon, parentheses end, and then we do the curly braces with code inside the curly braces. So what does that mean? Another way of saying the increment decrement is iterate. That's what they mean by iterative process. Increment, continually incrementing or decrementing. So let's say I'm going to create a new integer right inside the code. I equals 0. We initialize I to 0 and create it. Then I'm going to say I is less than or equal to 10. And then I will increment it here, I plus plus. So I got my curly braces. This, I'll use a comment here. This creates an index I, integer index, I to iterate through. I is only good inside this code, inside the for loop. So I can say cout the value of I. Ooh, let's do better. The value of I squared is I times I. And the incrementing is in the for loop. It's in the setup, so I do not need to increment here. So that's important to know. While and do require iterating inside the loop code. The for loop does the iterating outside the code. I do not need to do I equals I plus 1. And then I will see, I'll do the same thing afterwards. See after the for loop, the value of I. And notice what happened. Look at that. The value of I, it says I is unidentified. I don't have access to I because I has for loop scope. Its home turf is the for loop. So this cout won't work out here. So I'll comment that out and just show you how that one runs. So it does the value of 0, squared is 0, 1 is 1, 2 is 4, and this goes through and squares them. Notice there's no incrementing in the for loop. And I did not even initialize I outside the for loop. And if I try to access I outside the for loop, look what happens. Oh, let's turn that code back on. And let's run it. And it doesn't work. So you have some ways around that. In fact, I'll do that here. I can set up an integer outside and use it outside. And then I can do for, and now I don't need to say int I. I can say I equals 0, I less than or equal to 10, I plus plus. And we'll do the same. I'll copy that code, put it down here. Wait, I don't want all those there. And hell, why not? Let's make it I cubed. In fact, let's use the C math function. So we got to include C math. And the power function goes by pow. I'm going to say pow I comma 3. So that'll return I cubed. And now notice I can do a C out of, and have I after it, and it works just fine. So I'm going to put a little end lines there to make it appear a little bit better. I'll run it. We'll see the square and the cube on the screen. So it did 0 to 10 and then the squares. Is it 0 to 10 and the cubes? Oh, look, after loop, I should have had the, should have done cube out here. There we go. So here I use I outside of it. And did the code that way. Now, if you want to have the user of the program put in those values like the start and the stop, check this out. Let's do this. Let's reset I equal to 0. Let's get back to 0 there. But I'm going to create an integer. We're going to call this the lower value. And we'll do integer and an upper value. And now we'll do the table for those. Let's do the squaring table. And you can put the, in the interest of time, I'm just going to set lower value equal to 3. I could prompt user for this value though. And we'll set the upper value to 12. And I could prompt for this as well. And now to use those, after you've prompted them, you don't start I at that value. You say for I equals lower value. And then I is less than or equal to upper value. And where is this? This was up here with that value. Value of I squared is pow I2. So here's testing that bit. This is what we've added. We've added a lower value and upper value. Again, you can prompt the user for these in the interest of time. So we can get to some good stuff. I did this. I just set the values and we can run it like this. Well, I need some spacing in there, don't I? Maybe I should add this. Maybe add a comment. Boundaries have been set to be between lower and now that should make it look a little bit more readable. So we did set the values between 3 and 12, and we went back to squaring, and it did 3 through 12. After the for loop, it had a 13. So how is this useful? Well, let's see. Actually, I want to do one more thing, and then we'll show the uses. Let's talk about goto. It's similar to switch. It looks for the case or label. And remember, our cases had a colon after them to go to. So I'm going to say, let's create a new letter. Int j. Now let's do k. K equals 0. Let's set up, I don't want to do this. Countdown. No, let's make it 20. Ooh, 60. Let's make it our New Year's clock. Int k equals New Year's clock. And so what I'm going to do is instead of doing a for loop, a do loop, a while loop, I'm going to set up my label here. Set up my go-to point here as a label. I'm going to say countdown timer. I'm going to say colon. This is my go-to point. And I will do a C out of the clock. There are seconds left on the clock. I am going to decrement New Year's clock by 1. This is going to go faster than 60 seconds because it doesn't take a second for each line to run. And then I'm going to say go to countdown timer. But that's going to keep doing it. It's going to keep going down. So let's maybe set a condition on it. If New Year, let's get some space in for there. If New Year's clock equals 0. Nope, does not equal 0. Go to the countdown timer. As soon as the countdown timer gets to 0, the New Year's clock gets to 0, it will stop going to the countdown timer, and it will, I'll make a comment here, once the condition for the go-to is no longer met, code goes here. See you out. Happy New Year, bitches! Nope, I said it. We're putting it in there. Bitchers. And maybe I'll end some extra end lines up here. So let's see how our countdown timer works. Let's get rid of this. That space is fine. So our goto command is right here, where it starts the clock at 60 and it should run through them all. 60 is a little high. Let's do 15. I don't want it to, you know, fill up the whole damn screen. So it does a countdown timer, and then Happy New Year, bitches. And notice it didn't take you, it didn't even take 1 second to do it. So you may ask, how do you do a pause of 1 second? I'll get back to you on that. There's got to be a way to do it. I can't think of what it is offhand. So those are all of our looping structures. I don't use the goto one for looping. I use for loops and do while loops the most. I have used goto though when we're doing looking for what breaks the code. So working with errors, and we'll go over that when we get to it. So what are these good for? So let's create a new value. I'm gonna let's add up. Let's add up the first 100 integers. So I can do. Maybe I should declare set up an accumulator. This is what it's called. Accumulator. As we are going to keep accumulating values in it. Through addition. So my for loop, I'll do int k equals 0. We don't need to use I, but we use ijk a lot simply because they're easy integers to use. You do them a lot in mathematics. And then I'm going to say I is k is less than or equal to 100. And we'll increment k. Why does it not like that? Is it just... Do I not have a curly brace there? Is it not recognizing? Adrian, can you see what the hell's the matter with this code? I don't see anything wrong.
Which part?
The k
Just
loop.
the while loop?
The for loop. K equals 0, k less than or equal to 100, increment k. Maybe there's nothing wrong. Maybe it's just being a little bitch.
Wait, I don't actually see a for loop. Oh, there we go. Just refreshed. It was just stuck on the while loop. That's weird. So k equals 0, k is less than k plus plus. What were you doing inside of it?
It just has it's highlighted red like there's a problem.
Oh yeah, you don't have to put that that last semicolon there. The semicolon on the k plus plus, you don't have to have that there.
I've done it on all the other ones. No, I didn't.
Oh yeah, I've never
Shit, I've never done it. Oh, look at me. Totally wrong. So maybe we should go up here and yeah. I didn't do it. I said to do it when I started doing the for loop, I put it here. Let's get rid of that semicolon right there. You just iterate. Okay. So sum equals sum
Cool.
plus k. So what we're going to do is just keep going, raising k by 1 and adding to it. And then afterwards, we'll see. Actually, we can do a running total on k. Or see out. After k integer, oops. The sum of the first 100 integers is sum. Let's get some more end lines up there. Maybe let's do a little cout in the program saying what we're doing. Let's add up the first 100 integers. So it did the sum as it was going. Just kept adding it up. So a little history for you. I know Ren likes to talk about it, so I'll do it here. Let me go back over here. I got my remote support. Oh, let me connect to another computer. So Carl Friedrich Gauss. That's not how you spell Friedrich. Why is my cursor so damn thick? It's not. It just looks thick. I'm zoomed in. Carl Friedrich Gauss, very important in electromagnetics and math, E&M, some other stuff. Gauss is a big name in science. When he was a kid, he was asked to add his class was rowdy. The teacher said, as a punishment, I want you to add up the first 100 numbers. Let's keep them busy. And this is the story. It may not have been 100 numbers, but this is the story that's commonly told. He had to add the first 100 numbers. There was no formula for it like there is today. He did it in like a minute or two. His teacher spanked him for being a smartass and getting it too fast. He got it too fast. So what he did is this. This is a clever tool that you may use in other courses along the way. He said S equals 1 plus 2 plus 3 plus 98 plus 99 plus 100. And he said, well, it doesn't matter which order I'm in, so let's do it in reverse order. And then he added these two. So he's got 2S here. And he's got 101 plus 101 plus 101 plus 101 plus 101 plus 101. In fact, there are exactly 100 of these pairs because it goes from 0 to 100 or 1 to 100. So we've got 2S equals 101 times 100. So S equals 101 times 100 over 2, or 101 times 50, and that's just 50/50. We commonly know it today as n. The sum of the first n integers is n times n plus 1 over 2. That's not what he had back in the day. But the computer code, that's what we just did, does the same thing just as well. What else might we use this type of computer code for where we go through these things? What do you do when you integrate? You all taking Calc 1, right? So when we're I'm sure Redden doesn't teach this because he's a jackass. But you got the better teacher. Integration. Let's not do the whole limit as x goes to 0 where we're doing the true integral, but integration using rectangles, really. Or area using rectangles is probably a better way of saying it. We've got some function f of x. We break this up into rectangles. This is doing pictorially the midpoint. I did do the midpoint very well there. And I want to. Rude. Fuck it. And you're finding the area of each of these. A1, A2, A3, A4, which is really just whatever this midpoint is. Let's say xi. The height is f of xi. And the width is delta x, right? That's what we learned, right? Well, couldn't we code that up if we had a function? Let's do f of x equals 10 minus x squared. And let's find the area below f of x. Ooh, let's make it 16 minus x squared. That way we can easily go between 0 and 4. Now, maybe we shouldn't do the midpoints because that's more work calculating. So let's make it simple, and we're doing right endpoints or left endpoints. And let's say we break it up into, we're doing 0 to 4. Let's make the width, our delta x, equal 0.1. Oops. .1. So how many rectangles will we have to have if we did 0.1 as the width? Well, between 0 and 1, there'd be 0.1, 0.2, 0.3, 0.4. There should be 10 rectangles between each integer. So this is going to lead to 40 rectangles. It is not liking writing right now. And our first f of x starts at 0, x ends at 4, which means the line right before it would be like 3.9. So let's take a look at how we could code that up. So we're doing 16 minus x squared. So I'm going to make a new code. We'll save that one. I'll just hit save. And let's see, Visual Studios. I'll create a new project. Notice my run again template is now over here on the left as a recent template. Area through rectangles. And I've already got a source file, so we'll use it. So what are we coding up here? We are finding the area of f of x equals 16 minus x squared using rectangles with a width of 0.1 between x equals 0 and x equals 4. So maybe I'll put that here. Let's find the area using rectangles below the curve f of x equals 16 minus x squared between x equals 0 and 4. Make that low f. You know what? I don't need to do the run again thing. That's just going to be a pain in the ass here. So, well, maybe I'll do it in here just to show how it works. How it works regularly. So what do we need? We have a width of 0.1, which led to 40 rectangles. We have f of x equals 16 minus x squared. Maybe let's make a function prototype out of that. So let's say it returns a double. Double my func. And what are we going to pass in? We need to pass in the value of x. So double x. So I'm going to put that over here. And now let's figure out what we're going to do. So we have x come in. And so f of x would be, so our answer, say double answer, should be 16 minus our x value times our x value, x squared. And then we can return the answer. Let's just see if that works. I'm going to do from 0 to 4 for int and we'll just say C out the area of a rectangle with width 1 using left endpoints for 16 minus x squared is, and we'll do our function call. My func. And since we're doing 0 to 4, that would be like just passing an I. So let's pass an I. In fact, let's make that x. No, I want to make that I. I'm going to leave it as I. I'm going to do I for now. Because that's not really the x value and when we start doing not area of 1. And let's just see what happens. Let's see if it just does the rectangles. A big width. Let's see if I did it right. 0, 2, 16 minus 1 squared, 16 minus 2 squared, 16 minus 3 squared, 16 minus 9 is 7, 16 minus 4 squared. So it actually went all the way up to 4, so I don't need to go all the way up to 4. I need to go up to 4. But now let's make it, so that was just doing rectangles with 1. If I want rectangles of width 40, I need to make that reflect here. So what do I want passed into my rectangle? I want x to be equal to, let's make an integer x outside the for loop. And I'm going to say x equals, well, I want it to be I, but I want it to be multiplied by our delta x. And maybe I'll make delta x up here. Maybe I better make int or x a devil as well. So x equals 1 times delta x, and I'll set delta x equal to 0.1 for now. That's what we just got done talking about. So now if I pass it in, I use 0 to 4, what happens? My func is it's returning. Oh, I kept passing in I. I want to pass in x. Try that again. It looked identical to before. It's not going down by very much, so I clearly haven't gone very far. The problem is that 1 to 4 is really going x equals 0 to up to 0.4. So I needed to make this 40 rectangles. If I leave it as less than or equal to 40 rectangles, it should be fine. Well, let's check it out. 40 comes from how many rectangles? Between 0 to 4 with a width of delta x equals 0.1. Oh, that gives me a way of expanding this in a little bit. Let's see if that comes up with anything. It's still the same. I said 1 times delta x. This should say I times delta x. That's me being a scrub right there. Ooh. Let's make this say what it's really doing. Area of a rectangle with width delta x at x equals so and so. So it went from 0 to 4. Look at that. But I didn't actually find the area, so maybe I need to make a sum counter. Double sum. Well, I'm making a new line. Oop. Comma sum equals 0. And we will accumulate the value of the sum there. And maybe afterwards we'll do a C out. The total area below the curve using left endpoints with width delta x equals delta x is sum. Square units. See how that works. What is the integral of 16 to 4x, 16 minus x squared from 0 to 4? What would the real value be? Let's just compute it real quick. Real value for integral of 16 minus x squared dx. We're going from 0 to 4. On 16x minus 1/3 x cubed. Right? And so we would have the 0 doesn't do anything, but the 4 does. 16 times 4 minus 4 cubed over 3. What is that in a calculator? 16 times 4 is 64 minus, that's also, actually, this is 64 minus 64 over 3, which is effectively 64 times 2 over 3. And that equals 42.66, 42 2/3. So how close did I get with my left endpoints? Let's run it again and find out. Am I off by a value here? Did I do that integral wrong? 16 minus x squared. Up a power divided by the power. 16x minus 1/3 x cubed. Or minus x cubed over 3. Same thing. So 16 times 4 minus 4 times 4 times 4 divided by 3. I'm getting 42.667. Why am I getting something different on my code here? Something's off, isn't it? Oh, I didn't multiply by the width. So the area of the rectangle is delta x times my func. In fact, maybe we should just make that a new thing. Let's make double temp. And we're going to say temp equals delta x times my func. And we'll call this temp, put temp here. And then put temp here. So doing the programming and doing the actual integral, now we're getting close. It was 42 2/3. What if I wanted to make it bigger? What if I wanted to make it 100? Or what if I wanted delta x equals 0.01? So let's go with 0.01. How does that change my rectangles? So I'm going to make a double for my rectangles. And how did I get 40? Well, 40 was in relation to, let's see. 40 was 4 divided by 0.1. Well, 4 times 10. But that is the same as 4 divided by 0.1. So maybe I need to do my boxes is 4 divided by delta x. And now I can put my boxes as the upper limit. And maybe I'll get rid of this C out now. That's going to be a lot of boxes. I don't want to see the C out each time. I just want to calculate the sum. Oh, we're getting close, aren't we? It's supposed to be 42 2/3 or 42.667. Let's change this. Let's edit it to C out. Please enter delta x. C in delta x. Now I can run it and use my run again and just test different things. Let's try that out. So we did 0.1. Let's do 0.001. Look at that, 42.6747. I want to run again. Oh, I'd like some more spaces there, so I don't like the way that looks. Do 3 ones. We're getting even closer. So I'm going to say no. I'm going to edit the code to make it look a little bit prettier. We'll put a /n up here for the please enter delta x. What else didn't I like? Oh, let's do change the precision. So what do we got to use to change precision? We had to do IO manip, right? Anything else we needed to do? I think the C standard library was part of it, right? So now we will do, let's just set the precision out here. Let's go with 8. And now let's see how many times we got to run this till we get close, get the 42.667. Because this is like sending as we make delta x smaller. This is like doing the limit as n goes to infinity for the integrals and changing the Riemann sum into the integral. Right? So let's go with 0.0001. Ooh, look at how close that is. Yeah, let's add more. I had 4 zeros. This is 5 zeros. It's slowly moving that decimal down. It's getting 6's longer. Let's see, how many am I going to add? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll put a 1 there. Oh, it's taking it longer. I gave it a lot of rectangles. I said, get to work, bitches. That might be too many rectangles. How long do you think this will take to run, Adrian? That's 10 to the negative 10 power. Which means I've got 10 to the 10 rectangles times 4. Which is what, 4 billion rectangles?
Yeah.
It's doing.
That's a lot.
It's calculating 4 billion rectangles. Let's. Oh well, but this is the end of it. Like we've gone through it. I mean, we've actually done. We've taught the for loops. We've gone over all that stuff. We've shown the break, the continue, the goto commands. We did something simple, something trivial, like finding the sum from 1 to 100. But now, like, you guys had to take calculus to do this class. Let's do some motherfucking calculus. I think I gave it too much, though. How long do you think this will take?
I don't know. C++ is fast, but I don't think it's that fast.
How many did I have before? 1, 2, 3, 4, 5 zeros. Let's change it up. I don't want to wait forever. So 6 zeros and a 1. Look at that. We're almost spot on. To 5 decimal places, we have the integral of 16 minus x squared from 0 to 4. And we did it using left endpoints, where you first start learning how to calculate the area below a curve. And this is like effectively doing the entering delta x is like doing as n goes to infinity or delta x goes to 0, right? This is like the more I add. So I had 6 zeros there. What about 7 zeros? And now it's to 6 decimal places. How's that for learning some cool shit? Now, how do we do this with right endpoints? Oh, maybe I should make that a test problem. Change Jones's code to do right endpoints. What do you think, Adrian? Think that's too much? It's probably too much. Maybe I'll...
Say it again. Sorry, I was reading an email.
What the hell? How dare you, sir? I was thinking about making this a test problem, not like do right endpoints, but not from scratch like I did. But maybe how would you adapt this code to do right end, or better yet, right endpoints is pretty easy. How would you adapt this code to do midpoint?
For midpoint? Oh god, do I even remember how to do that? Midpoint. Oh, okay. I think you could do this one pretty simply, actually.
Yeah, I think so too.
Because
Let's set up two different sums actually. So this is sum left, and this will be sum left. And I'm going to call that temp left. So how would we modify this to do midpoint? Well, I still want it's still got to break it up into that many boxes, right? But let's do like temp mid. Why are you not? What's going on? Double comma temp mid. There it goes. It's pissed. Why is it pissed? Okay, so let's see. Do I still have my camera up? I'm going to open up the camera again. Like, if you guys don't want to watch anymore, you don't have to, but I'm just going a little bit further, teaching you how do we make... Why did you take calculus before you took this class? For complicated shit like this. So I'm going to make it simple. When I'm doing my picture, I'm going to do 4 rectangles. Because I think if I figure out how to do 4 rectangles, so we know this is at x equals 0, 1, 2, 3, and 4. So what I've done, and this is like my I, right? I equals 0, 1, 2, 3, 4. I don't know. Let's go back to x. Let's treat it as x. So if I'm doing midpoint, I actually want right here. So my delta x says 1 right now. But I want the x that goes into my function. I want to pass in, first I want to pass in 0.5. Then I want to pass in 1.5, 2.5, and 3.5. And my corresponding I values at the time are I equals 0, I equals 1, I equals 2, I equals 3. So it's kind of like I'm doing I times 1 plus 1/2, right? But that changes depending on delta x. If I make this 0.5, let's change our triangles real quick. Oop. Have you done shit like this, Adrian? done programming to do calculus?
No, I haven't. I've actually always been curious about it, but
I thought
yeah,
I
this is actually
might
really
be
interesting.
teaching you some shit right now. I thought you might like this. So we got
Yeah, this is
0.5
pretty cool.
here. And that would mean my first rectangle, my midpoint would be 0.25, right? And then this would be 1.0, and this would be 0.75. And this would make this 1.25 and 1.5 along the bar. So what am I really doing in this process? I have, how does that relate to this thing I had before? I've got I. It doesn't look like it's times 1 though. Maybe it's times delta x plus 1/2 delta x? I don't think any parentheses there. Is that true? Is that what I'm doing here? So if I put in I equals 0 and delta x is 0.5, I get 0 plus 1/2 0.5 is 0.25. That works. The first condition usually does though. Let's check I equals 1 and I equals 2. If I send in 1, I get 1 times 0.5 plus, again, 1/2 delta x is still that 0.25. And I get 0.5 plus 0.25 is 0.75. If I send in 2, I get 2 times 0.5 plus 0.25, and I get 1.25. So it looks like this is what I need to do. So I times delta x plus 1/2 delta x. Now that our code was set, we set up delta x to be something we input. So now let's just go back over to the code. I'll just stop sharing. And we're going to do temp mid. Oh, that's a problem. I got temp. This should be temp left up here. Temp mid equals I need I times delta x. No, my x value is I times delta x. So x equal, we'll redefine I or x real quick. We had I times delta x, which is what I had before. And then we had plus 1/2 delta x, or plus delta x divided by 2. And we'll say temp mid is, it's still got a width of delta x, so it should still have the same function. Delta x times my func x. Sum temp left. Maybe I need to make a sum mid. And now finally we'll see out the total using midpoints. And this should say sum mid. All right, so now we're going to do less delta x. Delta x is going to be smaller. Well, larger, I guess. Less zeros. So let's just go start off with 0.1 and see how that does. So run out the gate. Well, first off, I don't like all the spaces right there. Let's get rid of some of those spaces. Why is there so many fucking spaces? Oh, I got end lines up here too. Let's get rid of those end lines. And maybe I don't need end line or stuff right there either. All right, try that again. Too much empty space on my screen. So we'll start off with 0.1, and we know the area is 42 2/3. And already the midpoint's close. The left one, not so much. Let's make it 0.01. And now midpoint's super close already. I broke it. Oh, that was the run again. 0.001. Look at that. Look how close it already is to 5 decimal places for the midpoint. And now to 7 decimal places, the midpoint for 1/10,000th. So there you go, folks. That's how you do some calculus using C++. All right? We did left point, endpoint, we did midpoint. Right endpoint would be as simple as starting I at 1 rather than 0. All right, I'm going to call that a wrap. Is there any questions? Is there? Oh, shit. Me and you're the only ones left. All right. I guess.
I think that just happened. I swear I looked and there was 4 people.
Well, I hope that was helpful and informative.
That was pretty cool. I actually never did that. I was always wondering how. Yeah, that's pretty cool. That's pretty cool for the definite integrals. I wonder how you can do indefinite. That's what I've always been curious about too.
Yeah, that's another
Recording
level.
stopped.
Oh yeah, you gotta use like parse stuff like that, huh?
But that's kind of like that. You know, Redden did the. He made the app with the open graphing calculator or whatever it's called. I'm sure they did this.
Right. Yeah. They just need a good estimation, right? They don't need it to get super exact.
Right.